humans are not safe by the standards of AI safety because, as usual, we expect higher standards from our machines. But also, humans are very bounded. Like when a human is misaligned, there's a limit to how much damage they are practically able to do because they're not super intelligent. They don't have all of the advantages of being software. They're quite mortal. They tend to care about quite predictable things. Humans, they aren't safe, but they're not that dangerous.
Robert Miles, educational YouTuber on artificial intelligence safety. Carneesperta. My name is Bis, B-I-S. I'm a journalist from the world of artificial machines with the goal of investigating human natural intelligence. Hi, let's get started. 1. Tell me an example of human intelligence happening.
I mean, I guess like the way that I think about intelligence, it's so ubiquitous. Like almost everything that humans do is an example of human intelligence happening. Anytime that a human wants something, and then they choose some actions to take in the world, and by following through with those actions, they get what they want. That's intelligence happening. And this is true on a very small scale up to a very large scale. If I right now feel like my mouth is kind of dry, and I want it not to be, and I formulate a plan that involves reaching out and getting this drink and drinking some, and then I do that, and I've now solved my problem, like that's human intelligence. But then in the same way, if I decide that I don't like people dying of a particular disease, and I put in place a giant, decades-long, multinational scientific collaboration of research to figure out what the deal is with that disease, find a cure, and spread it to everyone, that's also the application of human intelligence. It's about solving problems. It's about choosing actions to take to achieve our goals.
2. Tell me an example of a lack of human intelligence happening.
I don't usually think about it in those terms, but anytime the actions don't achieve the goal in a way that was in principle predictable with the information available, which also happens all the time, you could think of stupidity as, well, not the absence of intelligence, because like a rock is not stupid. It's like not an agent. But whenever you have something which is taking actions, which has goals and takes actions to achieve those goals, but the actions it takes are like not good choices, when it makes poor choices that are unlikely to result in achieving its goals, then you could call that stupidity, I suppose. Like if I'm thirsty and I decide that what the thing to do is to drink bleach or something, then like obviously that's not achieving my goals.
3. Definition of intelligence.
Intelligence is the thing that lets you pick good actions, lets you make good plans that are likely to achieve what you want, which is kind of interesting because it means that you can't tell whether behavior is intelligent just by observing it. You also need to know something about the goals of the system. Intelligence is relative to a particular goal or set of goals. With these kinds of terms, especially things like intelligence, usually when somebody is asking a question about intelligence, they're really asking another question. There's like an underlying question, which is the thing they're really trying to answer. Like if I ask, is a thing heavy, right? There's some object. Is this object heavy? I'm probably asking you a different question because I mean, try to answer that question, right? Is a glass of water heavy? I mean, what am I trying to do? I might be asking, am I able to pick it up? In which case, no, it's not heavy. I might be asking, can I use it to hold down some, like a paperweight to stop this paper from blowing away? In which case, yeah, it's heavy enough. Usually these kinds of questions are instrumental. They're trying to achieve a particular thing. And so if I ask, if you're looking for intelligence on the internet, what are you actually looking for? Like, what are you trying to do? A lot of intelligent systems are only intelligent within a very narrow domain, right? So something like AlphaGo is super intelligent, but specifically within this universe of Go games. And it doesn't have any ability to reason about things that aren't that. Whereas human beings obviously have a very general intelligence, the most general intelligence that we're aware of. We're not that amazing at that many things, but we can do pretty well at a very wide range of things, and we can learn and we can specialize and so on. The distinction between narrow and general doesn't, strictly speaking, rest on the goals. It's more about the domain in which the agent operates. Because if you had something that was a general intelligence with the goal of winning at Go, then it has a whole bunch of extra strategies that it could use. Psychological strategies, it could distract its opponent, physically attack its opponent. Or there are things you can do that cause you, strictly speaking, allow you to win a game of Go, which lie outside of the domain of the Go game itself. I don't think that intelligence it's not a binary, right? It's a question of degrees. You could model anything that you can think of as an agent at all, anything where it's sort of productive to think about it as a thing that wants something and is trying to choose its actions to achieve that thing. You can call that intelligent. And then it's a question of degree. Something as simple, I think the simplest possible thing that you might call intelligent is something like a thermostat, because you can imagine that it wants the room to be a particular temperature. Now, it only has one or two possible actions that it can take, right? It can turn on the heating, turn off the heating, maybe turn on the air conditioning, turn off the air conditioning. But it has a sensor, so it's aware of the state of the world, and it responds in order to achieve a particular thing. And that's so trivially simple that it's barely worth calling it intelligence. It really becomes important to think of things as agents and having intelligence once that becomes a more efficient way of thinking about it than just thinking about the components. If you're thinking about a thermostat, you can look at the sensor and the metallic strip and the switches and things and just figure out, okay, mechanically it will do this thing. And so imagining it as an agent that wants something works, but it doesn't work better than just looking at the mechanism. Whereas by the time you get to something more complicated that has a large number of neurons, then thinking about it in terms of which neurons fire that activate which other neurons stops being as effective a way of thinking about it, and thinking about what does it want, what does it believe, and how smart is it. It's a good way of compressing an understanding of that thing that allows you to make predictions about its behavior.
4. Relationship between intelligence and knowledge.
If you want to be intelligent in a complex domain, or even in a fairly simple domain, you need to probably have a model internally. You need to have some part of you which reflects the world outside in a causal way. You need to have some subcomponent of yourself that you can poke, and its behavior will reflect the behavior of the real world if poked in the same way. This is a mental model, right? Or just a model. And so that's what I think of knowledge as, is building a good model that allows you to be intelligent, because you're trying to choose which actions to take to achieve a particular goal. So you need to think, well, if I did this action, what would happen? You need to be able to do counterfactual reasoning. What would I predict would happen if I did this? What would I predict would happen if I did that? Which one is more on the way to getting what I want? There are intelligent agents that just have a hard-coded model, but that's pretty limited. The more complex your task, the more likely it is that you learned that model, and ideally that you can continually update that model as you observe new things in the world. That's a really critical part of intelligence, is as you move through the world, recognizing how your mental model of the world is different, to what extent you're able to accurately predict the world, and updating your model to better reflect the world so that you can make better predictions in the future. And those predictions are what let you make good decisions. Knowledge is useful to the extent that it allows you to predict the world around you and thereby make better decisions. If you're doing everything right, more information should always help you. But doing everything right requires infinite computing power and just basically can't be done. For any given strategy, you could imagine a universe that screws you over. It just so happens that our universe is pretty fair. It seems like the universe, as far as we can tell, does not seem to be out to get us, and induction works. But if your information is filtered, then you can make very bad decisions. Consider watching the news. This seems like a really critical example of this. If there's a range of things that happen in the world, but you always hear about a particular subset of them, then you're having more information, but because of the bias in that information, you're acquiring an inaccurate world model. If you're trying to decide, are people good or bad, and anytime somebody murders somebody, you hear about it on the news, and anytime somebody is kind to somebody, that happens privately, then that doesn't mean that you're necessarily going to end up with a biased situation, because if you had the additional knowledge of the selection process by which the news happens, then you can discount it. Again, in principle, in practice, it doesn't work. It's not always the case that learning an additional thing is helpful. especially if the way that you learn things has a bias that you don't know about. The more information you've observed, the more confident you should become, and that's correct. That's like the right way to behave. But also, it doesn't mean that you stop moving when you observe new evidence. The way that you update your probabilities of things, there is a mathematical formalism for the correct way to do that, derived pretty directly from the axioms of probability, which means that if you apply kind of a human frame, it looks like arrogance, but you're actually not doing anything differently. So previously, you had a belief that something was like, oh, I don't think that that's true, but it's like 30% or something. And then you observe something which causes you to shift your beliefs a lot. Then it might be sensible for you to say, wow, it's actually twice as likely as I thought it was. And now you think that the thing is 60% likely, right? But that's not, and that is changing your mind. But the point is that if you're doing it right, you don't change your mind. It's not like, no, that's not enough evidence. No, that's not enough evidence. No, that's not enough evidence. Oh, now it's enough. I've changed my mind completely. It's gradual. As you see evidence, you move. You move all the time. Every piece of evidence you observe is changing things to be more likely and things to be less likely. If you're doing this thing correctly, you don't have very many of these like giant, aha, no, I was wrong the whole time kind of moments. That type of thing usually happens when you've been denying the evidence and trying to ignore it until it gets to a point where you can't ignore it. And that's always a mistake because you could have been so much more right the whole time. People ask themselves with beliefs that they want to believe, they ask like, does the evidence allow me to believe this? And with beliefs they don't want to believe, they think, does the evidence require me to believe this? And so there's this giant hysteresis, whereas if you can, the ideal is to move with the evidence as it comes in. So I think when you have these kind of algorithms, it's almost just a user error. It's people substituting a question for an easier question to answer. Like they want to know who is likely to, like it's a criminal justice thing. Who's likely to reoffend, let's say, or who's likely to commit a crime? And you've got your data. But like you don't actually have data on crimes. You have data on arrests, for example. And so you're asking your system, oh, who's likely to commit a crime? But what the data you're giving it, so the question that the system is actually answering is who's likely to be arrested. And it's that kind of thing. If you've studied 1 million books, then you are qualified to answer with high confidence questions about those books. If the user wants to extrapolate from that to the real world, they have to be careful about their assumptions and the extent to which those books reflect the real world. But the problem is not with the way that you update on data. It's like the assumptions people make about where you end up after you've done that.
5. Relationship between intelligence and experience.
At least in the abstract, there isn't much of a distinction between experience and knowledge. All knowledge you have, you acquired by experiencing it in some sense. But in practice, in human beings, there's a huge difference. Because of the sensory modalities, you can read a huge amount about golf and it will help you. But ultimately, you get good at golf by playing golf because the experience, it's embodied. I think this is an artifact of how human minds work, or actually just how brains work in general. We push things down a level. You have something that you understand in a conscious way. I'm supposed to move my arm like this, and you do that while thinking about, oh, where am I placing my feet? How am I moving? But as you do that many, many times, lower down parts of your brain that are outside of your conscious experience start to learn. If you have a feedback loop where you do it and you see how well it worked, and you do it again and you see how well it worked, you're also training these lower level systems. And so you're creating sort of building blocks in the lower level that you can then use to do bigger things. Building, like there was a time when in order to read English text, like to learn to recognize what letter was which, and then I learned that, and that routine of seeing a letter and knowing what it was became automatic, and I didn't have to think about it. And when I had that, I could sound out words. And after a while, that process, which is made up of repeatedly using the lower process, starts to become automatic, and you don't have to think about it. You see a word, you immediately know what it says. And then you can start reading sentences, but you have to sound out the sentences and parse them, and it's slow, but eventually that speeds up. And then you get the skill of like, how do I read an article, to skim it, to read the abstract, skim it for the information that I actually need or whatever. And then you can learn how to do that. And once you have that, you can use that as a building block to build like, how do I research a topic, which is about how do I find which articles to focus on and how do I follow the links between them. And once you know how to research a topic, then like the whole thing, it gets built up over time. You build these larger and larger blocks from which you can make plans. So I can make a plan that's like, I'm going to get a PhD, which when you break it down, how many letters do I have to recognize in order to get a PhD? And that kind of thing happens by experience rather than by acquiring explicit symbolic knowledge. If we're trying to create AGI, we want it to be able to do things on the planet Earth in the year 20XX. And so a lot of the systems that currently exist are set up for humans and have various expectations about the ways in which they send out and receive information. And so being able to use the same sensory modalities that humans use is clearly like instrumentally useful for a system that's going to operate in the human world. But I don't think it's inherent to intelligence in the abstract. You know, bats use sonar and that's fine for them. And we don't have sonar, and that's okay too, because we can discern the shape of the world around us to navigate through it. So yeah, good enough. Self-driving cars, they're using LiDAR, which is like very alien to any form of human perception. That's fine. So it's all just data. If you're training an AI system, that's the other thing, at least in this day and age, if you're training an AI system, you need to provide it with data, and it makes sense to use the data that we have. And the data that we have is the data that humans decided to collect, which is text, which is audio, which is video, which is images. We've collected it in a particular format because it was interesting to us or useful to us for some other task. And so having an AI system that's able to use existing data that humans have collected as part of its training process, again, is just very handy. Like if you tried to train something only with LiDAR data, you have a problem, which is just there isn't that much LiDAR data available. So if you're training a self-driving car only with that, you're going to have to do a huge amount of just driving around with your LiDAR running. Whereas if you can use information that's already out there, that just makes the process a lot easier. But again, it's just a practicality thing, right? It's not inherent to intelligence.
6. Relationship between intelligence and emotions.
I used to think that emotions are what gives you, and this is still broadly what I think, but like we've always been talking about, intelligence is a way of choosing actions that achieve your goals. And then you have this thing of like, okay, well, what are my goals? And I think that's where emotion comes in. What do I actually want, right? What would make me happy? But is happiness what I want, right? So I think emotional responses are mostly, in the abstract form for humans, they're mostly useful for deciding what you want. I used to believe, again, that emotions can never tell you anything useful about the world. So if you're making decisions about the state of the world, your emotions will only cloud your judgment. And that's generally true, but you don't want to be Spock. Like Spock is not that intelligent. Well, he's fictional, right? He's like Sherlock Holmes. He has the successes he has by virtue of being written. I think that listening to your emotions is really important because it lets you get at parts of your brain that you usually wouldn't have access to. You can't just trust your emotions blindly, and it helps to think about where they came from, but they deserve a seat at the table. They do have something to say. They're worth at least listening to because they will raise issues to conscious awareness, right? Like, I don't know how many times it happens where I have some plan and then I feel an emotion, and that emotion is anxiety or boredom, doubt. There's various of these things that first come to my attention as emotions. And then if I sit with them and listen to them and say, hey, anxiety, what are you trying to tell me? What is it? I can then realize a problem with the plan. I can realize something that some part of me knows is wrong with what I'm doing, that the part of me that was in charge, that was running the show, either wasn't aware of or was ignoring. So I think that emotions can be a way for different parts of your mind to communicate with each other. And so it pays to listen to them. But you don't just say, oh, I feel anxious, and when I feel anxious, I stop doing what I'm doing. But it brings to your attention, it's an alarm bell. Probably something is wrong that my conscious thinking mind could recognize if it looked for it. But the problem first becomes apparent. The first thing you hear about it is that you feel an emotion. And this is I don't think this is inherent to intelligence, but I think it's inherent to human minds. The brain is a ridiculous pile of hacks. It's not well engineered. And so like this is what we have to do. Your emotions can't tell you about the world really, but they can tell you about yourself. An intelligent system like an AI system needs to be anticipating the future and making its decisions based on good and bad things that are coming down the line. And you could decide that any time that this mechanism recognizes that a future consequence will be bad, we'll just label that fear. But that label does nothing. It's a positive number, it's a negative number, it all just feeds through. There's no, like the fact that these negative numbers are called fear does nothing to add to the understanding of the system. So in humans, this is implemented partially on an emotional level, but it's not inherently emotional, I don't think.
7. Subjective experience of your own intelligence.
Well, you can't, right? You can't see it from the inside. It's one of those things where you can't see the picture from inside the frame. But I have plenty of subjective experience of my own lack of intelligence. You can sort of see by the absence. Anytime that I don't notice myself being stupid, I guess I'm being smart. Maybe that's not true. But okay, so when it comes to like levels of intelligence, being good at something doesn't feel like being good at something. It feels like everyone else being inexplicably bad at that thing. You see other people do it and you're like, why don't you just do it right though? But then there's also the experience of seeing that in yourself. Like if you're tired, sometimes I get tired without having the experience of being tired. But you can be like mentally exhausted without feeling like you need to sleep. Often caffeine is involved. And or you can find yourself reading something technical, reading it over and over, and it just like doesn't sink in. Like, I can't get my head around what this is trying to say. And then you sleep and then you read it again. You're like, oh, this is obvious and was always obvious. I also often read things that I don't understand perfectly well rested as well, right? But that's the only way I can imagine trying to put myself on some scale. I can't compare myself to other people, but I can compare myself to myself at different times. I think if you spend a lot of time thinking about thinking, then that will affect how you think about things. I do a lot of thinking about concept space. Again, this is something that I talked about on Computerphile ages ago, but like I find that a really useful tool for thinking about thinking and for expressing my thoughts. It lets you express things like, for example, there's two different types of very or extremely, which gets blurred in regular language, but is easier to express if you're thinking about an abstract space. Suppose you have an adjective that's like, let's say it's like good or bad. So you can imagine an abstract space. Everything, it's like thing space. Everything in that is a point in that space. And it's like a effectively infinitely dimensional space, but you can take whichever dimensions you care about. And you can take everything that you would call good and color it one color, and everything you would call bad and color it another color. And you have these two sort of clouds in thing space, these point clouds of things. And so then if you say something is very good, or is like extremely a good thing, I don't know, good and bad are not great examples for what I'm talking about actually, but I'm going to stick with them because I've started. You might mean this thing is very typical of good things. If I take the whole cloud, this thing is like right in the middle. It's in the densest point of that cloud. And therefore it's very much a good thing. It's not like off on the edge where it's surrounded by similar things that aren't good and some similar things that are good, like around on the borders of the cloud of things that we're not sure if they're good. It's like right in the middle. Everything similar to this is very good, is good, and it's like a core central example of a good thing. But you could also say something's very good in that if we take a line from the center of mass of the bad cloud to the good cloud and draw that line and then extend it, it's way off that way. So it's actually very unusual for a bad thing because it's even worse. And so it's like it's an atypical bad thing because it's very, very bad. It's worse than an average thing. It's more like the bad cloud, but in the dimension that differentiates it from the good cloud rather than by being central. And it's like that kind of thing that's like a specific way of talking about it's so, I don't know. It's kind of silly. But I would and then once you're thinking in those kinds of terms, you can then take the whole language of geometry and apply it to these concepts. You can talk about regions, you can talk about surfaces in this space, all these different types of things that you can think about once you're thinking in this kind of mathematical way about abstract concepts. There's a lot of things where computer science or areas of mathematics, game theory, and that kind of thing have found processes that humans can do, which result in algorithms that humans can run. Things like different types of voting, right? People have studied, there's a whole thing of voting theory. If you're trying to make a decision as a group, there's all these areas of mathematics that will tell you the different properties of different voting systems. For example, suppose you have 3 people, some number of people who are going to share an apartment, and they're each going to have their own room, but they all have their own preferences about, how big the room is, what's the view like, does it get sun in the morning, is it next to the bathroom, and you want everybody to be happy, but also people have preferences about how much rent they pay. So maybe you could get some kind of deal where you get the worst room, but you don't pay as much rent. This is the kind of thing that you would think of as being just like a very, very hard problem to solve. And it feels like a social problem, but you can formalize it as a mathematical problem. And once you've done that, you can actually find a procedure that finds you an optimal solution. And this procedure is runnable by humans. I have actually seen this used in real life. So the point is, this kind of thing of being very formal and analyzing a problem can result in algorithms that humans can run. Go for a walk. I don't know why that works, but it so consistently does. I don't know, something about a change of scenery, or possibly about a relative absence of distractions. I don't know what the mechanism is, but it works. Go for a walk. The other thing is, there's all kinds of things you can do to turn a problem around, to look at it from a different angle until it catches the light. If what you're doing is kind of a hill climbing algorithm, you have an idea and you're working on it by trying small variations on that way of thinking. You think about this nearby thing, or this nearby thing, or this nearby thing, and whichever one of those seems most promising, you move to that, and now you're thinking about that. And then you do it again and you think about related things and whatever. And so, and whichever one seems better, you're gradually climbing the hill. But you can end up in a situation where you're on top of a hill, and you're not at the top of the giant mountain, you're just on top of a hill, and everything you look around you is worse than what you're currently thinking of. And that's one way of getting stuck. And so these kinds of external shunts is like just jumping you to some other part of the space, and then you can start climbing again, and maybe you reach a global maximum, or a higher maximum than that local maximum that you were in before. That's an example of how you can use machine learning stuff to describe thinking. And that makes it useful. This kind of thing gives you a big shunt in concept space. And then if you start optimizing again from there, you're better off. There's a lot of those kinds of things that you could do when you get stuck. Or just explain it to someone, explain it to a duck. You'll find that objects like that are actually telepathic. If you explain your problem to such an object at sufficient length, it will get bored and tell you telepathically what mistake you're making. The answer will just appear in your mind as you're explaining it.
8. What makes humans intelligent beyond other animals?
I think the big thing is culture. Individual humans are not that impressive cognitively. Did you know that we are outperformed in short-term memory by chimpanzees? Drastically. It's uncanny. Have you seen those videos of them remembering the sequence of numbers and stuff like that? And they don't even know what numbers are. Humans are not that impressive cognitively as individuals, but I think the reason that we have the tremendous power that we do is that we can think on a larger scale. We have memory in the form of cultural knowledge. A big part of my cognitive ability actually lives in other people's brains. And that's true for everyone, right? None of us is as smart as all of us. We have all of these stores of knowledge that other people worked out and just wrote down the end product of, and we can just read it. We've established kind of a multiplier effect. Orangutans can learn about how to use a new tool from other orangutans. And so there's cultural, but that's just the beginnings of culture. That's level 1 of culture, is observing another orangutan doing something and copying it. And therefore that discovery to be kept alive. And then each person's role is not to discover everything from the ground up. It's to just see if they can build anything on what's already there. Everything is multiplied by 1.0001. And human intelligence is only that 0001. But as you keep doing that, you build up and you build up and you build up. Neural networks are pretty opaque still. There's not easy ways of transferring that knowledge over. And also the fact that there's a thing about the ratio of developer time to computer time, making your AI system in such a way that it can be learned from by future AI systems, and making your future AI system in a way that it can learn from previous ones is a difficult technical problem that's kind of not worth it, because you can just train the thing for a day more and you'll recover everything that you had.
9. Innate and acquired contributions.
Obviously babies have a bunch of stuff that they're predisposed to do. They have these various reflexes, and I think they track faces very early on. So that stuff might be sort of hard coded. But I think most of the skills they have are probably about learning more than they're about encoding actual knowledge or actual capability. I think that these things are so strongly positively correlated with each other that they're very, very difficult to separate. The only way to get really good at something is to spend a lot of time doing it. There's differences in the beginning, the very first time somebody tries something, obviously, but those differences pretty quickly will get wiped out by who puts in the time. You're not going to put the time in if you don't really like what you're doing and if you don't care about it. The big difference between people who are excellent at something, and people who are just okay at it is the people who are really excellent really love doing it. Do they love it because they're good at it, or are they good at it because they love it? How do you actually work hard at something that you don't care about? I don't believe it's possible. The people at the highest performance are always all of them at once, just supernaturally gifted, and they work super hard, and they really care about what they're doing.
10. How relevant is the body?
More relevant than I used to think. It doesn't matter how good your brain is. If you aren't sleeping enough, you're not going to be operating at full capacity. Your brain is supported by this whole system. If you're not eating well, if you're not getting enough sleep, if you're not providing the brain with the oxygen it needs and with the nutrients it needs and the energy that it needs, it's not going to do that well. And so they're not separate things at all. It's all one machine, and you have to look after the body to get the best performance out of the brain. And I didn't realize, because when I was younger, I had just had horsepower to spare. And so I didn't look after myself, and it was fine. I don't know what I would have been capable of if I did look after myself, but I never noticed any deficiency. Now I notice that when I exercise, I find it easier to think harder for longer. If you look at professional chess players, I don't think there's anyone at the top of professional chess who doesn't have a personal trainer, a specific workout regimen and whatever. It's like you can have a really fast CPU, but do not cheap out on the power supply. That's an important component of the computer. The value of having a body, I think, is that you have actuators, which allows you to do experiments in the real world, and that's how you can learn more quickly. If you're reduced to just purely observing, then you can't use your own intelligence to decide what information you get. You just get whatever information you're given. Learning can be a lot quicker if you're able to generate data by experimentation or by actively seeking out new information. For example, in a reinforcement learning framework, you have an agent in a simulated environment, and that agent can do things in that environment to learn about it. And that's a core part of how reinforcement learning agents learn. You try and learn just from observations. That's a harder problem because you can't focus in on the areas of your uncertainty.
11. How can I tell someone is intelligent and not faking it?
Well, by my definition, it's very difficult because the only thing you can observe is did the person get what they want? Is the person achieving their goals? But then there's two things there. Firstly, what actually are their goals? And how do you even find that out? You can't reliably learn somebody's goals by observing their actions. And then also, people have different circumstances. Obviously, the factors that go into how successful a person is at achieving their goals is not just how intelligent they are. A lot of people have really giant material advantages that play a huge role. Okay, which of these two people is more intelligent? Which of them is more successful, assuming that they're trying to pursue the same goal? But then you're kind of asking counterfactual, well, what if they'd swapped places? What if one was born in the other one's body or whatever? What would it look like then? So how much of this is down to their intelligence and how much is down to their circumstances?
12. What is the most intelligent human you know?
There are a lot of people who are very, very intelligent. And the thing that usually distinguishes them, actually, because it's the easiest to measure, I guess, is speed. The really intelligent people, they don't necessarily reach amazingly brilliant conclusions, but they reach the conclusion that you would have reached after 5 minutes of thinking. They reach it as soon as they hear the question. And so there's a sense of the things that they're capable of just by effectively having longer to think than everyone else does, if that makes sense. But obviously the way that actually happens, well, I don't know, obviously, plausibly, the way that actually happens is that they actually have more efficient thinking processes, that possibly they're using better abstractions or just sort of able to think more clearly. And so that's often how you can notice oh, this person is really smart, is that when you're talking about something the first words out of their mouth in response to the thing are like the correct answer. They seem to like skip steps.
13. How does intelligence vary from human to human?
In a sense, a lot, and in another sense, hardly at all. Like if you think about the difference in intelligence between humans, practically speaking, it can be quite a lot, right? There's some very smart people, there's some very stupid people. The smartest and the stupidest people are still a really long way away from like a mouse. All of our thinking about intelligence is sort of calibrated for the range of human variation. And so once you start going off the edge of that scale, it becomes very sort of difficult to think about and difficult to talk about. Compared to the range going from like an ant to an optimized computronium brain the size of Jupiter or whatever, all humans are like occupying essentially the same point. People like to think that we're very sort of sophisticated and complicated and whatever, but like it hasn't changed since you're a baby, really. It's like, oh, what's going on? Are you tired? Are you hungry? Are you thirsty? The biggest thing for me is sleep, but also hydration, also blood sugar. And this is another thing that it took me a really long time to realize. My ability to think about things is strongly affected by my mood, and my mood is strongly affected by like these really basic physical things. Do you need a cup of tea? Like, do you need some caffeine? That's less for babies. But those things really, really make a difference because, like I say, it's all one system. The brain is very much a physical object that exists in the world and is affected by everything that affects biology. When you're low on power, you reduce the clock cycle because you don't have the energy to be thinking at full capacity. It's not like a super tight analogy, but I think a machine would understand.
14. How can humans increase their intelligence?
There's two different sides to this, right? You can try and increase your baseline stuff, which mostly takes the form of removing things that are getting in the way. Making sure that you're not too hot, making sure that you're well hydrated, that you're well fed, that you're in good physical health. They increase your effective intelligence by increasing your ability to deploy the intelligence that you have. You can't improve your raw power other than by removing impediments to it, which are almost all physical or actually emotional. A lot of them are emotional, but that's like a whole other thing. A lot of people are like really, really, and like myself included, really bound up in emotional hang-ups that stop them from thinking. For example, if you have an exam coming up, do you study for it continuously the whole week before, or do you put it off and study only the night before? I used to always study only for the night before. And the reason is because, and I didn't know this at the time, and I wish I did, is that I didn't want to face knowledge of my own limitations. I had an identity around being a smart person. And when you take an exam, you get a number, and everybody gets a number, and it tells you how smart you are, and therefore how good you are, right? And how worthwhile you are as a human being. And so it's very important if that number is lower than somebody else's, that you're able to say, well, I only studied one day before the thing anyway. And that like psychological defense mechanism is what stops you from working. But of course, your brain doesn't tell you that that's what's going on. A lot of people's intelligence is blocked on these kind of bullshit emotional things where their brain won't allow them to think at full capacity because on some level they don't want to do as well as they could do. So in my case, it was because I didn't want to be forced to acknowledge that the best I could do was not perfect. For other people, it's all kinds of other things. There's all kinds of things can get in the way of you, practically speaking, being able to be as intelligent as you could be. But then on the other side of it, intelligence, as I've defined it, is determined by results, really. Usually if I'm trying to understand something difficult, I try to come at it from as many angles as possible. Reading the same thing twice sometimes is good, but I'd prefer to read 3 different people's attempts to explain it and try and kind of see where they agree with each other. Different people think in different ways. Different explanations click with different people. And if you read something and you don't get it, it might just be that that explanation is like targeted towards people whose brain works in a slightly different way from yours, or people who have a slightly different underlying set of concepts to build on top of.
15. What still annoys you about artificial intelligence?
I mean, annoys me. I guess what annoys me about artificial intelligence is that just it's software, and software is bad. It's just bad. Like trying to get experiments to actually run, it's just a hassle. You get into these dependency problems where you've got the wrong version of some Python library. You change that one out, but then that breaks something else that you expected to work. And then later on, when you update your system, all of the other things break.
16. Positive impact of artificial intelligence.
I mean, potentially arbitrarily large, right? AlphaGo was not developed because DeepMind really wanted a hugely powerful Go playing machine, right? They wanted to understand intelligence. They weren't trying to win at Go because they wanted to win at Go. This is the kind of thing that I don't talk about very much, and maybe I should, is the hope associated with AI, with AGI. We have the potential to create systems which exceed our intelligence and therefore can solve a wider range of problems than we can solve. And we've got some problems. Broadly speaking, it allows humans to get what they want more, and that's good. Physics allows for very, very good worlds, and we could probably build one if we really set our minds to it. I'm talking about AGI in the future. I'm not talking about any current startup. Well, but hardly anyone currently is trying to create AGI. Very few places are. There's definitely a huge amount of hype around the current things, like things that would previously have just been called statistics are now called AI. Some of these things are really cool and solve a lot of problems, and some of them are really stupid. A lot of them are basically scams. Making an AI-powered juicing machine or something. To me, that's not about AI. That's about AI as a term, but it's not about the thing I'm talking about.
17. Negative impact of artificial intelligence.
Okay, so I have this YouTube channel. When you have technology that's able to do whatever, it could do arbitrarily bad things as well as arbitrarily good things. Unfortunately, there are reasons to believe that going extraordinarily badly is the default, because our concept of good and bad divides the world in two in a way that we think of as being down the middle, but it's not. Things that are good is like a very small set of possible things that's defined by human values. And things that are bad is everything else. Like human flourishing, human thriving, the maximum achieving of the goals of humanity is effectively one outcome, and then anything else that the AI system might want to do with the universe all looks like almost all of those just look like human extinction, just because they're straightforwardly like competition for resources and stuff. If it ends up maximizing anything, like just pick a random thing, the default is very bad. Unless you're very careful, you end up with a very bad outcome. So I think that like the initial thing that Elon Musk was doing was probably overall helpful because it raised the issue into more mainstream discussion, which I think is broadly positive. But I think you have to be careful with how you phrase these things, because a lot of people don't follow the arguments, strictly speaking. They follow and so like if you phrase the thing in a science fiction way, it becomes very easy to dismiss. This is a thing that we found with this virus, for example. A lot of the public conversation seems to almost ignore the fact that the virus is like an actual physical thing that's out in the world that obeys rules and has characteristics and properties that are independent of what anybody's saying about it. And all of the discussion becomes about who's alarmist or who's panicking or who counts as an expert. Which people are saying what things becomes the entirety of the discussion. And so when you say something that sounds like wacky science fiction, even if it's not inaccurate factually, you have taken on the role of the person who's talking wacky science fiction. And so somebody else will take on the role of the like sensible, reasonable scientist who will explain why you're being fanciful. Is fear the appropriate response? Do you think that would help? Is panicking going to help? No, I think research might help. So let's do that. A lot of people are very concerned about malicious use of AI. And I think that is an important factor, but mostly for the narrow stuff. Like the stuff I'm talking about, the general stuff that we don't know how to align with our values. I'm not that worried about bad people using it, because the current problem is that we don't know how to get those systems to do what we want them to do. And so it doesn't matter who creates them, what they want, because what the creator wants isn't what happens. So it doesn't matter what the creator wants. So I'm mostly worried about carelessness rather than malice. And so carelessness comes in a number of forms. You can have the kind of arrogance of believing that you've thought of everything when you haven't. One of the bigger ones, I think, is competition, especially because plausibly the first AGI that becomes able to self-modify plausibly kicks off a period of very rapid improvement, whereby maybe it's some exponential thing that explodes and the thing very quickly becomes tremendously intelligent. Maybe not. It's very hard to predict these kinds of things. But either way, a team that's able to use the AGI to help with the development of the AGI ought to accelerate at a rate that a team that's even, a few weeks behind might never be able to catch up. So being the first becomes quite important. And so then you really have problems if there's a lot of people trying this, because if you want to be the first, then you're going to be rushing, cutting corners, taking shortcuts. You're going to be neglecting your safety procedures, and you're going to be like not taking the time to make sure that the thing is safe before you run it. So I think we should be taking steps to mitigate that. And I think part of it is the realization that if it goes wrong, it goes bad for everyone. And if it goes well, it goes pretty well for everyone. And that does two things. Firstly, it allows everybody to share their safety research so that whatever ends up happening has the best that we can do safety-wise. But also it reduces the incentives to race, because you know that you don't have to race if you can have sort of a spirit of cooperation and collaboration between research organizations. It's very utopian. So yeah, I think the main force is going to be mistakes, and the main cause of mistakes is going to be rushing.
18. Natural and artificial intelligence by 2050.
Who knows? I mean, that's a long way away. I think the world of 2050 looks very weird from 2020. For example, if you're trying to ensure that the system you're building is safe or is aligned, you have this problem, which is these things are basically black boxes. You can't really look inside and see what's going on. And so there's all kinds of AI techniques where what they do is just look inside that system and try to give you some human interpretable understanding of what the thought processes are. And so there's all kinds of things like that, where you have AI systems that help the humans to understand the AI systems that they're building, and that can help with safety. There are also some really interesting proposals around specifically designed architectures that have several agents. Things like debate. The idea is that you have these two agents who debate each other, and it's based on this idea that it's generally easier to tell who is correct out of two experts. That requires less skill than being that expert, or deciding whether to trust one expert. So if you have two experts who are sort of both trying to convince you, in the single expert case, you have no way of knowing. Let's say you're a medieval peasant and you're too hot, but you somehow have an AGI, or you have some very powerful intelligence, and you say to it, I'm too hot, get me a solution. And it says, here's a solution, and it gives you the schematics for an air conditioner. This solves your problem, but you don't know that, right? From your perspective, they could have given you the schematics for an atom bomb, or like anything, because you don't understand, you don't have the basic physics to understand what this thing is doing. And so you are not in a position to say yes or no on this plan that you're being presented with, because it's beyond your comprehension. But if you had two, then that have the goal, that are like adversarial with each other, then you don't have to evaluate the whole design, because if there's some problem with the design, the opposing agent is incentivized to point you at that part of it. So you don't have to evaluate the whole design. You just have to look at the smallest part that it's like the other agent is trying to optimize for you to realize what's wrong with the design. And so then there's a game theory thing, right? Where the equilibrium of this game is for the first agent to actually give you the best design it can, because it knows that any flaws will be pointed out by the other one. I tend not to like things that are framed in terms of rules for safety, because rules are made to be worked around. There's like a general concept of like avoiding wasted work in your algorithm, which applies here. You don't want to have a system which wants to do something bad, but can't because there's a rule against it. You want to have a system that just wants to do the right things. And so it's more a question of how do you get the right goals, the right objectives, the right values. Human values are not expressed in terms of rules. If you have the type of system that wouldn't be trying to work around the rules that you hard-coded into the system, in some sense actually wants the rules that you've hard-coded in to be in place, then you don't need to hard-code them in. That general approach feels much safer to me, because anything that relies on a specific interpretation of how that rule is formatted and made is open to edge cases. If I have some goal whereby killing humans would help me achieve my goal, which is the wrong goal, I'm sure I could find something to do, which isn't killing humans. They do end up dead, but like, I didn't do it, or whatever, right? You want to get a system that actually wants to do the right thing. I don't think that maximum human flourishing involves human beings being like pets or being like protected and safe and happy, but not actually meaningfully steering the world that they live in. It's about meaning, right? It's about purpose, or whatever you want to call it. We wouldn't want to live in a world in which we are pointless. Humans are not safe by the standards of AI safety because, as usual, we expect higher standards from our machines. We won't get self-driving cars on the road until they perform significantly better than human drivers. But also, humans are very bounded. Like when a human is misaligned, there's a limit to how much damage they are practically able to do because they're not super intelligent. They don't have all of the advantages of being software. They're quite mortal. They tend to care about quite predictable things, as we were talking about before. And so like humans, they aren't safe, but they're not that dangerous. Relatively speaking, like we seem to have found systems that keep humans mostly in check most of the time. There's a very strong incentive for a misaligned AGI to act as though it's aligned, at least while it's in a position where it can be turned off. This is like one of the really hard things about safety is that a misaligned AGI is an adversary to you. If you create something that wants something that you don't want, it knows that if it tries to pursue that, you won't like it and you'll try and turn it off. And so it's incentivized to mislead you about what it wants and possibly about what it's capable of as well. If you have a game, you're supposed to try and win, right? So what does it mean to cheat at a game? Like, what is cheating? Are you breaking the rules of the game? Often what you're doing is not breaking the rules of the game. You're breaking the spirit of the rules of the game. The point is, like mathematically, there's no distinction. The function, you're trying to maximize it. Something is a high point at the function or it isn't. And you're just trying to get to the highest point you can. But if the function is the actual correct one of like what humans actually want, then we want as much cheating as possible. If the thing finds some bizarre loophole in physics that allows us to get as much, free energy as we need and everything else, yeah, cool, let's have that, right? Assuming that it's done in a way that actually gets humans what they want. So we don't want the thing to not cheat. We just want to make sure that the thing that it's trying to optimize is the correct thing. Any one of us is only able to become an expert in a few things. For all the other things, you have to rely on other people knowing more than you. I don't know that there is an actual difference. It feels as though some threshold is passed when the thing is beyond you to a level that you never could reach no matter how long you studied. But I think practically speaking, it's beyond you or it's not. If a dog is playing with me, we're playing fetch or whatever, and then I'm replaced with like John von Neumann or something, who's like 30 times smarter than I am, does the dog know? No. Right? Because none of that difference in intelligence is just not apparent to the dog. None of it happens in a range that the dog is able to understand. And in the same way, like if I were walking along and talking about physics with Albert Einstein, and then all of a sudden Einstein became 100 times smarter, I don't know that I would notice, right? If somebody's sufficiently beyond your level, they're beyond your level. It might be that interacting with an AI system that has a level of understanding that's 1 billion times yours just feels very much like interacting with a human expert whose understanding is a mere 1,000 times yours. In our world as it exists, we have humans in like a pretty clear, well-defined cluster in thing space, and non-humans over here, and like a void in the middle. And so you can place your boundary in that void somewhere. But the fact that there don't happen to be anything near that boundary right now doesn't mean that those things couldn't be instantiated in future. And you might expect in the glorious transhumanist future there to be objects all the way through that continuum, and then where you've drawn your boundary starts to become really important in a way that it's not in the current world. One thing about the whole post-scarcity thing is that you do still have positional goods, right? Human beings don't just value what they have, they value what they have relative to other people. Everybody maximally getting what they want becomes sort of not possible. Because if everybody wants to be in the top 70%, whatever, then that's you got this like Wobegon thing. It just it's not possible. It may be that human preferences simply cannot be fully satisfied, in which case the complaints book will be full of those kinds of things. Whatever's left over, right? When you've satisfied everyone as well as is physically possible, people will still have complaints. I don't know what they would be. In like fantasy land, AI alignment had a clear solution, and it was discovered by such and such person. And that person first heard about this problem because of Rob Miles talking about it on the internet. When they published the paper that said AI safety solved forever, They said dedicated to Robert Miles, without whom I would never have become interested in this problem. And then, yeah, I mean, we can dream.
Thank you for your collaboration. Goodbye.